During this video, we are going to review the concept of valence shell and valence electrons for transition elements. Okay, in order to determine valence electrons and valence shell for an element, we have first to determine the electron configuration of that element. Okay, remembering that valence electrons is the highest energy level in the electron configuration, and valence electrons are the electrons that we have in the electron in the valence shell. Okay, so now let's review an element from the transition area. Remembering that transition elements are the ones that we have in the B groups, the ones that we have in the center of the periodic table. Okay, so we have, for example, iron. Iron, which has an atomic number of 26. Okay, we are going to determine first its electron configuration. So I will start with my first level of energy, 1s2, 2s2, 2p6. Remember to follow the order of the off-both diagram, okay? 2p6, 3s2, 3p6, 3p6, here's a 6, 4s2, okay? So we have 6, 8, 10, 16, 20, 22, okay? And then after 4s, we have 3d, and let's see with how many we have to complete it. So we have, so far, we have 2 electrons, 4, 10, 12, 18, 20, and since we have to reach to the 26, this level D is going to be filled only with 6 electrons. Okay, I know that sublevel D can hold a maximum amount of 10, but since it's the last one and I only need 6 electrons, I will only add the 6 electrons that I am needing. Okay, so this is the electron configuration for iron. Okay, since it is a transition element, the valence shell will be the highest energy level in the electron configuration, and everything that we have to the right. What is this? Which is the highest energy level in the electron configuration? Okay, is the 4s2, okay? And I will take everything that is right to the right side of 4s2. So the valence shell will be 4s2, 3d6, okay? Remembering what we just did in the previous video of the valence electrons and valence shell for representative or elements in the A group, okay? What we did there was taking the highest energy level, in that case, the 4s or the 3s or the big numbers that we have. In this case, since we have a transition element, the valence shell will be the number that we have the highest energy level and everything that we have to the right, okay? So will be 4s2, 3d6, okay? The valence electrons, okay, will be the same. The electrons that we have in the valence shell, so in this case will be 2 plus 6 will be the 8 that we have, okay? But now, how can we relate the position of the element in the periodic table just by having the valence shell? And that's what we are going to look right now. Okay, just let me erase this. Okay. So we have here the periodic table, okay? Just what we have in the previous slide was that for iron, and I'm gonna write it in here so we do not forget it, for iron, we have a valence shell that was 4s2, 3d6, okay? And the valence electrons was 8, okay? So how can we determine the position of the element just by looking to the valence shell and the valence electrons? It's going to be something similar to what we did with our representatives. The period of the element is going to be given by the highest number in the valence shell. So in this case, since I have a 4 and a 3, I will take the highest one, in this case 4. So the period in which we will find the element is period 1, period 2, period 3, period 4. Okay, this is period 4. And the group, okay, in which we are going to find the element will be the valence electron. So here we have an 8. If we look to the position of the groups, okay, counting them in a sequence without skipping the transition area, we have that this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here we have iron. So with the valence shell for representative and for transition, we can know the position of the element in the periodic table. Because for all the elements in the periodic table, it's different, its valence shell, well, it's different, its electron configuration, and it will be different, the valence shell and the valence electrons that we have, okay? So if they give you just the valence shell, you can know which element we are talking about or which element has that valence shell without doing all the electron configuration of all the atoms, okay? Just by looking to the valence shell, we can know in which period, okay, and in which group we have it.